So hello everyone, welcome to my YouTube channel. Today we will solve first problem which is there in the lead code, which is called two sum problem. It is easy level problem. Let's read the problem statement. Given an array of integer nums and an integer target, return indices of the two numbers such that they add up to target. You may assume that each element will have exactly one solution and you may not use the same element twice. You can return the answer in any order, right? So what is given in the question? They have given an array, right? And they have given a target variable. You have to find two indices. When you sum that two indices, you get the target, right? So let's say if you sum 2 and 7, then you will get target 9. So you have to return these indices. That's why the output is 0 and 1, because 2 is at index 0, 7 is at index 1. So that's why the output is 0 and 1. Let's see the second example. Here let me do indexing 0, 1, 2. The target is 6. Now what we'll do, we will check 3 plus 2 is 5, which is not equal to target. 2 plus 4, 6 is equal to target. So what we'll return, we will return 1 and 2. So 1 and 2 indices, when they are added, it becomes equal to target, right? So this is the problem, and the problem is the target. Another example is target is 6 and we have to return 0 and 1. Here only two indices. When we sum the indices, we got the target variable, so that's why we will return 0 and 1, right? So I hope you understood the problem. Now what is the brute force approach to solve this problem? What can be the brute force approach? Brute force approach is simply we will use two nested for loop. What this for loop will do, one for loop will iterate the array from I, another for loop will iterate the array from j, and then we will check whether array of I is plus array of j is equal to target, right? Two for loop will be there, one for loop for I, another for loop for j. I will start from 0, j will start from 1, and then what we will check, we will check if array of I plus array of j is equal to our target. If it is equal, then what we will return I and j indices. That is it, right? So this is a brute force approach. Using two nested for loop, we will solve this problem. Now what is the time complexity? Time complexity, we are using two nested for loop, right? So the time complexity will be order of n square, n for I and n for j, right? So that's why the time complexity is order of n square. And what is the space complexity? Space complexity, we are not using any space, so that's why space complexity is constant. So this is a brute force approach. Now let's talk about another approach, or optimize approach. What can be the optimize approach? What we can do, we can create a map, right? We can create a map. We can store the element when at what indices the element is present, right? Let's do a dry run with a sample example. Let's say array is 2, 7, 11, 15. Let me do indices as well, 0, 1, 2, 3. So what we'll do, we'll create a map. So we will create a map. Map will have elements, map will have num, and map will have indices, index of that element, right? We will traverse from I, right? We will start from here I. We will check, and the target, what is given, target is, let's say the target given is 9. So what we will check, we will check if the remaining value will be target minus array of I. If this condition is true, target is 9 minus array of I is 0, so array of I is 2. Is 7 is there in the map? Initially the map was empty, right? So 7 is not there. So if 7 is not there, then we will store I which is array at array of, we will store the index at which it is present, 0 2, right? Then we will increment or we'll move ahead. Now I will be here. Now we'll again use the same formula, right? We will calculate remaining. So now target is 9 minus array of I. Here array of I is, array of 1 is nothing but 7. 7 minus 9 minus 7, 2. So is 2 present in the map? Yes, 2 is present. At what index it is present? It is there in the map. It is present at index 0. So here what we'll do, we will simply return I, because I is the index of the we are traversing, and we will return map of 2, map of the element, right? Map of the element 2, right? So this is by creating an hash map and storing the number and indices of that number, we can solve this problem. Let me take another example so you will get your concept more clear. Let's say the array is 3 4 9 2, right? This is the array. Let me do indexing as well, 0 1 2 3. So this is array we have given, and what is k, which is target, right? Okay, or let me write target to be more clear. We have given this array, we have given the target. Let's say target is 6, right? Now what we'll do, the first step is we will create an empty map, right? So the first step is we will create a empty map, right? It is having two things, is the number and index of that number, at which index it is present, right? We will store that. Initially the map is empty. Now what we'll do, we will traverse, right? We will traverse from the array. I is here. Now what we'll do, we will write one formula, right, to check if the remaining element, see if the remaining element is target minus array of I is 0 here. So for this I equal to 0, for I equal to 0, what is remaining? Remaining is target is 6, 6 minus 3 is a 3. Is 3 present in the map? No, initially 3 is not present. So what we'll do, we will store the element which is at array of I. We will store element and the index of that element. So 3 is present at index 0. We will store that, and we will move ahead. Now I is here. So for I equal to 1, so if I is 1, then what is the remaining? Now remaining is target is 6 minus array of 1. Array of 1 is 4. 4 is equal to 2. Is 2 there? Is 2 is present in the map? No, 2 is not present in the map. So what we will store the element and the index of that element, right? Now we will increment I. I is now here. So I will become 2. Now we will calculate remaining. Remaining will be 6 minus array of I. Array of I is array of 2. Array of 2 is 9. 6 minus 2 minus 3. Is minus 3 present in the array? No, minus 3 is not present in the array. So what we will do is minus 3 not present in this map. So if minus 3 is not present in this map, so what we will do, we will store 9 and we will store index of that 9 2, right? Now we will increment I. I is here. Now let's say I equal to 3. So let's again calculate remaining. Remaining is 6 minus 2, right? Because array of 3 is 2, so it is 4. Now 4 is present in the map. Yes, 4 is present. Where it is present? It is present at index 1, right? So that we got the pair whose sum is equal to the target. So what we'll return, we will return I, and we will return map of 4, right? So this is how we can solve the problem, using by creating a map and storing the elements and storing the indexes of that element. And we will use this formula, remaining is equal to target minus array of I, and we will solve the problem, right? So this is the dry run for this code, right? Let me write the code. Okay, so the code is what we have to return. We have to return indices, right? So indices, we have to return 2 indices, right? Because 2 sum. So what we'll do, we'll store in the vector. Let's say the question is 2 sum, right? And it is taking an vector as input as well. Let's say it is array, and it is taking target. So this is a function that we have to code, right? Now what we'll do, we will, let's say, initialize, we will take n, we will do nums, we will do array dot size, we will calculate the size of the vector, right? Now what we will do, we will create a map, and we will create a map. Let's create the map integer, right, mp. Now what will, now next is we will traverse for int I equal to 0, I is less than n, I plus plus, right? And then we will calculate remaining, integer remaining is equal to target minus array of I, right? So when, if mp dot find is remaining, right, then is not equal to mp dot find, then what we'll do, we'll return. So here this we are checking whether this mp dot find remaining is present, or here I think it is end. Is we are traversing the map and checking whether this remaining element is present in the array or not. If it is present, then what we'll return, we will return mp of remaining, and we will return I, because that is the two indices that we have to return, right? Otherwise, if it is not present, then we are just, then what we are doing, we are just storing in map, we are just storing in the map. So how we are storing in the map, we are just mp of array of I equal to I, right? We are storing the element in the map. So this is how you can store the element in the map. And then what we'll do, let's say if this is not there, then we'll return empty, right, because there is no indices. So that's why there is no two element whose sum is equal to target, so we'll return empty vector, right? So this is how you can solve two sum problem, right? We will create a map, then we will traverse through the array, we'll calculate this formula remaining target minus array of I. When we find the element, then what we'll do, we will return the indices. Otherwise we will store in the map, we will store the current element in the map, right? Now what is the time complexity of this problem? Time complexity, we are traversing the array 1, so time complexity is order of n, right, because worst case we will traverse the entire array. So time complexity is order of n. Space complexity, we are creating a map, so we are storing all the elements which are present in the array. So what is the space complexity? Space complexity is order of n, right? So this is the optimized approach to solve two sum problem, right? The brute force approach was taking order of n square, but the optimized approach is taking order of n, but the space complexity is also order of n. I hope you understood the problem. Thank you for listening.